same problem as before, but B, a recovery device comes to remove oil. The rate at which it is here. Here's the rate at which it removes it. If it's removing, isn't that negative rate? It's taking it away. The oil continues to leak, so this keeps going at this rate. Find the time for which it reaches its maximum volume. So to find a maximum volume, aren't you going to set the derivative of volume? Aren't you going to set the derivative of volume equal to 0? Isn't that what we're looking for? For problem B, we're trying to find when the derivative of volume equals 0, and then you want to find where it changes. We want to go from the derivative of then we want the derivative of velocity to go from positive to negative, correct? With the derivative of velocity, then go from positive to negative. So, how do we find the derivative of volume? Sorry. Well, isn't this the rate at which the volume is leaving? Isn't this the rate at which the volume is coming? So isn't the rate, I'm going to put dV dt. Is dV dt the same as V prime t? Two different forms. Isn't the rate at which the volume, isn't it going to be 2,000? That's what's coming in. And isn't the rate at which it's coming out simply 400 square root t? Isn't that the volume? Now can we then just set this equal to what? Like we said here, don't we set that equal to 0? And when you solve that, I will tell you the answer. It's actually pretty simple, because couldn't you just move this over, divide by 400, square both sides? You end up with t being 25, and that's minutes. So t is 25 minutes. That is where it's a possible max or min. How do we make sure that's actually max? Because don't you have to verify it? And it probably is, since it's the only answer. Let's see. I wonder. Yeah, it probably is. But let's check. How do we check? Don't we have to check that the changes from positive to negative? So could I basically plug in times on both sides to this? So to prove it, could I, when I plug it in, could I find V prime of, say, 20? Find out what that equals, and do V prime of 30, and find out what that equals. And when I do that, could I plug those values into here? And what I'll end up noticing is it goes from positive to negative. Does that verify that this is a max? If I verified it and I plug the values in, that would verify it is a max. So at t equals 25, it is a max. Now, should we also check the endpoints? Should we also check the endpoints? Well, if it starts off at this, it's growing. If you think about the concept, you could check the endpoint. Basically, you could, actually don't even worry about the endpoints. I'm not going to do that. Now, let's do C. We're not going to worry about the endpoints. C, the recovery device begins when there's this much oil. We're going to write but not evaluate an expression that tells you the volume. So, if I want to find the volume, well, wouldn't that be, what's it starting at? We know it's going to start off at this amount, correct? And then from there, aren't we still going to be probably adding? Isn't oil still coming in? Isn't this the rate at which the oil is coming in? If this is the rate at which the oil is coming in, how do we find out how much volume it is? Well, if this is a rate of volume, can I integrate that to get the amount of volume? So don't you basically take the integral And what would be the interval? From 0 to... Oh, by the way, the oil found in part B. In part B, how much time was it? 25. So that way from 0 to 25, how much oil before it hits maximum? Now, from there, what goes here? Can't you put this? Could I put dVdt? Could I write that, or could I write the formula? Could I write either one of these? Yes. Let's write this. Wouldn't this right here give me the amount or the volume? That is simply my equation. And that would be, that's all it is.